Good day, viewers. In the previous video, we measured the substructure aspect of our perimeter fence. We measured trench excavation for the fence itself, and we also measured pit excavation for the gate columns, 3 columns. So in this video, I'm going to measure the superstructure part of our perimeter fence. Let me switch off this. Okay, so from our section, sorry, from our elevation, the height of the fence here is 2.185. 2.185. So the 2.185 is applicable to the fence from this part down to this other part. Why the fence here in the front part of the building is a little bit different from the fence, the other fence. We have like a special design along this part. So I'm going to measure this separately, and I will measure this separately. I'm going to measure this from our elevation. I'm going to measure this from our elevation. Well, I'll measure the other part of the fence on our side plan. In doing that, I'm going to make use of this plugin under superstructure, finishes, masonry and plastering, external block. I'm going to make use of this plugin. I'll rename it. I'll rename this as fence block work. The width here, I will leave this as 0. The width of the block actually is not 0, is 225, since we since our trench excavation was 675. But if I should input 25 here, the outcome of this particular plugin will have a width of 225. And what I have here is just a straight line. So I want the plugin to appear as a straight line, so I'll be able to trace this properly. That's why I want to maintain 0 here. Why this will be 2.1 2.185 is what we have on our elevation. So after that, I'll click on OK and trace this from this point down to this point. Then I click on escape. The next part of our perimeter fence is the front part. I'm going to measure that on our elevation. I want us to take note of this dimension. The distance from this place to this place, according to the side plan, is 17.1. I'll use that in dimensioning the elevation. 17.1. So the total distance from this point to this point is 17.1. Scale 17.1. That will be from this part to this other part. Okay. Let me use the text height. Now, the fencing along this path, I want to measure that with the aid of our plugin. I'm going to measure this with the aid of our area 2 because of the nature of what we have here. Like the height of the fence is not uniform. You have that design here. So the height is uneven. So since the height is uneven here, I'm going to make use of my area 2 for proper measurement. So the fence wall. So what I'm going to do now is to trace the area, this area. I made a mistake in my previous measurement. Let me deactivate this. Okay. So we'll trace it that way. This will give us the area of block that is required. Yeah. Okay. So this we are done with the measurement of the block wall. But we also notice that we have pier at 3 meter interval. We have piers at 3 meter interval. So how are we going to measure those piers? In most cases, our pier is usually combination of two block laid in opposite direction to the fence block itself. If you know, whenever you're constructing fence this way, the you lay the block wall in using stretcher bond, using stretcher bond. But when you get to the location of the pier, you lay the block wall in the opposite direction. Take for instance, if our wall is coming this way, when you get to where that pier is, the wall will go this way. So to go this way, this way, while the fence will continue in that direction. So what should happen in most cases that we have two block laid side by side in this form whenever we have K. So we have stuff like this to like break the length of the fence and also serve as to serve as aesthetic purpose too. But the main purpose of that breakage is to like strengthen the wall. If you just have your block wall laid in this form without break at interval this way, wind could easily pull off this type of fence if this pair is not there. So this is there to like give it strength to add to the fence stability. So how are we going to measure this care? In measuring this pair is very simple. What I'm going to just do is we're going to like count the numbers. What I usually do is I'll count the numbers of pay. I'll count the numbers of pay. Then after counting, I will now do like manual calculation to get the area of block what is required. Like what we have here, we have how many pair here? We have one, two, three, four. This is a column. 5, 6, 7. So we have 7 pairs here. Since we have 7 pair, I'm going to multiply. Let me do it this way. Pair. I have from here 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 pair here. Yeah. We're going to count those on the distance itself, on the other part of the fence. Let's just take care of this first. So we have 8 pairs here. Since we have 8 pair, for each pair, since our block will be laid in this direction, so that means the area of block that is required will be the front part of the area of the front part of the block of a normal block times 2. Let me put up a drawing so you understand what I'm talking about. Okay. Next. Control Z. Let's now have our block this in this form. So for pair we have double block this way. Okay, so we have double block this way as our pair. So to now get the area of pair, what we're going to do is that we're going to multiply the height, the length of this of a block by the height of this pair. The length of one block times the height of this pair times 2 for this and this times the numbers of pair. So that's able to calculate the area of block that is required to form those pairs. The length of a block, distance from this point to this point, is 450. So what we'll have there is what? 450 times this. That will give us the area of one of this block times 2 because we have double block at each point times the numbers of pair. But don't forget that we have 2 block wall in substructure. So that means we're going to add 450 to this. Adding 450 to this, I'm coming. Let me quickly do that. I'm going to add 450 to that. 450 plus what we have here is 2185. So that means the height of our pair will be 2.635. 2.635, while the length of the pair is 450. And we have times 2 times the numbers of pair. Let me deactivate this. I'm going to work on this pair. Advance. The quantity here is the numbers of pair we counted the other time times the length of a block is 0.45 times the height. What do we calculate that time? We calculated 2.6 what? Sorry, okay. We did 2185 plus 450, 2.635, 2.635. So this will give us the number. So this will give us the area of block that is required in forming those pair. And the unit here, we have to change this unit from EA to square meter. Square meter. Okay. So that's the area of wall. Sorry, something is wrong. Advance. Okay, P. I have a P here. So that's the area of wall that is required to form those pairs. I want to calculate the pairs we have on the other part of the fence. Let's quickly count the numbers of pair on the other part of the fence. So add them to what we have here. According to this elevation, sorry, according to this plan, the plan of this elevation, we have our pair is spaced at 3 meter center to center. So let's go back to the other plan, to the side plan. Okay. So on the side plan, the length of this side plan is 76.80. 76.80. That's the length of the side plan. So now get the numbers of pair we have along these parts, the other part of the fence. What I want to do is I will divide this length by the pair spacing, which is 3 meters. I want to divide 76.8 by 3. Back to my calculator. 76.8 divided by 3. So we have approximately 26 numbers of pair on the other part of the fence. Approximately 26 numbers. So I'm going to multiply what we have here by 26, or what should I do? Okay, let's see. Advance. Okay, I want to add 26 to this. In doing that, this is for the other 8 number. I want to add 26 to it. What I want to do here is I will put the whole thing here inside bracket. Then we'll now add our 26 numbers of pair to this. Let me copy this. Copy, paste, times, this is the area of a pair, times 26. And don't forget that the whole calculation here is just for one of one block word that make up the pair. And for each pair, we have like 2 block word laid side by side. So at the end of the day, I want to multiply the whole thing here by 2. I want to multiply the whole thing here by 2. In doing that now, we have to highlight the whole thing and multiply it by 2. Multiply by 2. That gives us the area of block that is required to make those pairs. For each pair, we have 2 blocks. What we calculated the other time before multiplying by 2 is the area of 1 block that is required. That's required for making this pair. The area of 1 this way. So multiplying by 2 now cater for both this and this. I think that's clear enough. So with that, we're done with measurement of the block wall, and the area of the block is same as the area of finish that is required. The area of the block is same as the area of the finish. Did I? Okay. I'm going to delete this. No, 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 no. Let me leave it. If I should delete this, this will also go along with it. But the since this is the area of the block wall, this other block wall here, we're going to like render depending on the setting here. It's possible that you have to like render both the external and internal part of this wall. But if you have like if this building is located where we have like other existing buildings and we have like you have a neighbor here and you have a neighbor here, a neighbor on the other side, you might only have to like render the internal part of this alone. To render the internal part of this alone, the area of that plaster is same as the area of the block wall, which is this. So let me delete this. No, this particular plugin is for block wall. Sorry, for block wall in building itself, not it's not meant for fence. You just use it for fence. And I'm going to change this to internal. Let's assume that we have existing buildings on the left and right part of this block, and even on the rear part too. That we have existing buildings. So I want to we're only going to render the internal part of this internal. Let me change this external to internal. Just an assumption. Internal. Then our fence wall here is this other part. The area of the okay yeah, for this particular part of the wall now, we're going to render both the internal and external parts because the internal and external parts belong to the owner of this building. The external part of this is for another person, while the external part of this is for another person. The external part of this is for someone else. But the external and internal part of this particular fence here is for this person, the external and internal part. So I want to multiply this area by 2. That will give us the area of the plastering that is required. What did I do? Sorry. Undo. Copy. Paste. Yes. And I'm going to multiply this by 2 because I want to render both this part and the other part, the internal and external part. Internal and external plastering. Advance. I want to multiply this by 2. Take off. Multiply by 2. Okay. We don't need this. Let me leave that. Okay. Let's not forget that we actually measured the pit excavation for the gate column, but we're yet to measure the column itself. So let's quickly measure the column. The height of the column will be the same as the height of our block wall here, which is 2.63, if I'm not mistaken. And in measuring that, I want to make use of our plugin. I think that plugin is under tile to isolated column, concrete column, concrete column. Numbers of column. We have 3 columns here, according to what we have on elevation. We have 3 columns. Thickness. Let's assume that the length and breadth of our column is 600 by 600. 600 by 600. 0.6. 0.6 by 0.6. After clicking on OK, what you are meant to do is to trace the height of the column after clicking on OK. If you look at what we have on our elevation, come and click on OK and exit and escape. Escape. We have to improvise. If you look at what we have, if you look at what we have on this section, it's just the superstructure part of this, the superstructure. And if you remember the other time, the depth of our excavation was 1 meter. Yes, 1 meter. So that means our column will be okay. I'm coming. So this is the depth of our excavation, 1 meter. While our column base is 300. If you subtract 300 from 1 meter, what we'll be left with is 700. So I'm going to reduce this to 700. I have to improvise since we don't have the full section. 700. 700. So the distance from this point to this point will now give us the height of the concrete that's required here, here, and here. The height from this point to this point. So I'm going to trace that now. I've inputted the required details here. 0.0.6. Let me just confirm. Yes, 0.6, 0.6. Then I'm going to trace this from the base. Let me activate it. I'm going to trace this from the base right to top there and click on escape. So now I'm done with measurement of the concrete column, this column, this column, and this other column. Reinforcement 16 mm, bar width, numbers of column 3, numbers of straight bar 4, bend 200. Okay. Then our stirrup. We don't have detailed drawing here, just like improvise, just show you guys how to measure um, perimeter fence. Bar width, center to center spacing, numbers of side B, numbers of side A, side B 0.6, side A 0.6, hook 200, cover, numbers of cover 2. Okay, then down to the formwork, numbers of column 3. So with this, we are done with measurement of the concrete work. The last thing I'm going to measure here in this video is we have this design, this special design. Let me put this off. We have this special design here. In most cases, it's usually precast. Precast. So for precast item, what we need is just the length. That precast item is part of the finish. It's part of the finish. This video is somehow long, so I'm going to cut it short here. Then I'll make another video. In that video, we're going to measure the finish to this other part of the fence, like finish to the pier and this other precast um, concrete work. We also measure, we also take off for the gate itself and this barb here, this iron work here.